Hi, mathematicians. Today we're looking at Thursday, May 27th. This is lesson 17, and we're going to start putting some surface area calculations now that we are experts on making nets and labeling them. So when we are calculating the area of a figure, what are we finding? Yes, the area is the amount of space inside a two-dimensional. So it's all of this space here. Surface area is similar to area, but surface area is used to describe three-dimensional figures. And what do you think is meant by a surface area of a solid? It's just the surface area of a three-dimensional object. Just like we had that cube, each face was covering it. So it's just like covering or wrapping a present. And what type of figure does the net create? In this one here, exercise 1, we're going to be making a rectangular prism, okay? And how many faces are on this? You are correct, there are 6. So here's 1, 2, 3, 4, 5, and 6. Okay, so I'm going to zoom in a little bit here. So let's start by just labeling these. So this is 1, 2. We're going in centimeters, so this is 2 centimeters all the way down, all of these pieces. And it looks like we're on the sides, we're only 1 centimeter. So 1 centimeter. This would be 1, 2, 2, 1, 1. And then these are 2. Okay, so after we have been able to label it, it's kind of cool on this one because it's on a grid paper, so we know how much each one of these sides are going to be. But we know if it's 1 by 2, so this is going to be 1 centimeter by 2 centimeter, that first one will be 2 centimeters squared because we have centimeter times a centimeter. Let's do this as number 2. This one will be 2 by 2, so we know that that is 4 centimeters squared. We'll keep going down. 3. This one will be a 1 by 2, so that's 2 centimeters squared. Face number 4 is a 2 by 2, so it is going to be 4 centimeters squared. Here we have 5, and that's a 1 by 2. And then the last one is also a 1 by 2. Okay, so how many do I have all together? I have 1, 2, 3, 4 times 2 is 8, plus another 8. This one will be 16 centimeters squared. And if I went and counted the boxes, let me grab one more pen color. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, and 16. So pretty nice and neat that it works out that way. Okay, we also could look at this and say, I know that I have 2 perfect squares, so I could do 2, sorry if you can see that, 2 times 2 times 2. So this would give me 4 and then 8, plus, how many of these sides did we have? 1, 2, 3, 4. There are 4 of those sides, so 1 by 2. So this would be 4 times 2, which would be 8, and we also get 16. So you can make the formula a little bit neater and nicer too. Let's take a look at the next example, and hopefully you're doing this on your paper as well. Let's write all of our information on this one first. And this one is unique because it is with the triangle. So before we start, we are going to drop where the right angle would be. We can see that this is a base of 3, and it looks like we're doing feet this time. 3, and then this one, even though it's coming up here, it's 1, 2, so that's 2 feet. Okay, so we have a 3 by 3, and what is our formula for the triangles? We're going to do a half of 3 feet by 3 feet. And how many triangles do we have with that? Yep, we got 1, 2, 3, 4, so we could times that by 4. So let's do that. Oh, it's not 3 feet, it's 3 by 2. So 6, half of 6 is going to be 3 feet squared, And now we're going to times that by 4. So all of our triangles are going to get us 4 feet squared. But then we need to think about our last face, which is the base. And that one is a 1, 2, 3 by 1, 2, 3. So it's 3 by 3, and that will give us 9 feet. So we're going to add those two together, 12 feet squared plus 9 feet squared, and we get 21 feet squared. Okay, I know you've probably been doing some of these already in your head, but I like the way that this curriculum is doing it step by step. Nets can be very hard sometimes. All right, hopefully you've got all your examples written down and you're ready to start doing some of the exercises.